Now our second unit is, first unit was using AI in robotics. As we know, if AI is not there, then our robot is dumb. It is just program machine. It has got hardware. It has got general movement programs. It is not having any power of thinking or taking decisions or learning. Similarly, another aspect, we need vision for our robot. That is what eyes of robots are camera. So our second unit is now dedicated to setting up vision setup and some pre-processing techniques of the view. All of you know that how vision is important for robot, because vision acts as a feedback in our process, because it gives interface to designers or users to the actual task happening. Before go to all these things, all of you know the configuration space is broken up in three parts: observable configuration space, non-observable, and partially observable. Meaning of this is, whenever operator or user of robotic setup is on console, this user or operator can see configuration space and robot, or totally not possible or partially possible. Whenever environment is free, robot is in good atmosphere where illumination light is there, operator can see. But whenever robot is in field or areas like mine where illumination is not possible, then how do operator can know task is completed or not, or what is happening? Sometimes that configuration space can be broken up into partially visible, and still things can be managed. But there are certain problems where we cannot have visibility at all. For example, furnace work or high melting point materials are there. Whenever we use heatings, whenever we have very high electrical field, in such environments robot cannot enter, or robot is in different environment other than earth. So many times you have to rely on the simulations, or you have to rely on the projections. Many times sensor data may be accurate, may not be accurate. These are non-observable environments wherein we provide simulations and we work on simulations, not on real view. But in non-observable environment, the problems are very high, but partially observable environment and totally observable environment, things can be managed. So in this particular problem, or in this particular unit, we have to see many such practical conditions also. Many of you may be thinking, sir, what is exactly non-observable environment? Sometimes in the mechanism, let's say we are tightening screw at engine bottom. Do you expect visibility over there inside engine? Answer is no. Many times our workspace may not allow, or our mechanisms of use may not allow that much light and freedom to visualize everything over there. Another example, suppose I'm having small glass object or metallic object and a very small text is there. I want to check whether that logo is printed or whether that particular thing is written correctly or not, its size and variation, everything I have to check. Do you think really on conveyor in industry, do you have sufficient light like whatever photographs you take miserably in real life? So that liberty is not there. Hence, in all these conditions, robotic vision setup is very important. Installing camera is one part, getting view is second part, but having favorable conditions is a major part. That's why in this unit we talk about illumination, how to provide light and exactly position where we want to take camera. Similarly, we will talk on different cell layouts because we have to again arrange all these camera parts and all these operations correctly in orderly. So first part of robotic vision is setting up camera, setting up vision system. So in this unit we'll talk about basic components of vision, how to set up the camera. There are different parts over there, like what are different types of offsets, what are different parameters when we acquire the view, what is distance effect, what is lens effect. So various effects are there. Then we'll talk about illumination, cell layouts. After that we acquire image, we have to pre-process the image because that image may not be perfect for processing and operations. Then we need to find out different parts or we have to break image. This is what all we discuss. During all this discussion, we'll go for some industrial robots which are proven systems wherein we'll be talking about camera applications. Now, what is robotic vision? Robotic vision is a process of extracting or finding out visual information from images. Obviously, camera and other advanced devices will be there. Today, this is very important industrial operation. Most of robots now rely on camera because camera gives real view. So that inspection, recognition, pathfinding, part finding, sorting, very important operations can be done very easily. It has got low cost. Nowadays, camera technology is developed, so we can afford cameras on the robot. From mechanical point of view, engineering point of view, it is passive measurement, that is non-destructive measurement, non-contact measurement. So camera can be used for measurements also. It's low cost, low power. It has got good capturing ability. So in industrial robots, camera is doing miracles or more advanced and accurate methods can be developed. In these all operations, robot is perceiving surrounding and interacting with surrounding and giving us visual information. Many industrial operations are made very easy. For example, inspection of the welding joints. Of course, previous sensor based or human based or manual methods may not be that much efficient and accurate. But now we can have camera, we can go for every and each and every joint. So many of you are mechanical engineer now. You can imagine how many welding joints are there in a particular operation, and checking all of these joints from point of reliability is very important, because we are having different mechanisms, right from small object to the ships or aeroplanes. Everything is inside. So how to check quality of each joint? Otherwise, there will be failure. So vision-based operations provide you this facility. Now, some applications for your reference. Some universities are working on this. So some papers these are given to you, also links. So path following, person finding. So provided that on a mobile robot cameras are installed, so you can find path. Now, right now somebody asked me question about wavefront planner. Look at this. These are the actually wavefronts showing directionals in real application. So see that objects are very dark. And remember, that was only coordinate grid. This is real life scene. Look at where is the free space. That is white one. And we need to find path in that. Okay, then different object detections. So all these are what you can say some advanced or good applications in mobile robotics, because that is what bit complicated. Like some more applications. Somebody asked that question upon planners. So how to find path, person following applications, face recognition, door detection, because you need to find entry or entry point. So you need to find doors. Okay. Now let us discuss. It is time to discuss now basic robotic vision system. Now robotic vision, that means camera assisted to the robot. What are objects in our system? Is the robot along with camera. Then where we want to see or what we want to see, that configuration space in real world, and obviously processor or camera is connected to that, and a light source, either natural light or artificial light. So these are basic components of robotic vision system. So we have a camera, then real life light is falling on that camera, connecting all the scenes, and later on we process that scenes on computing. One step ahead, let us break this block diagram into sensing and digitizing. So now light source, either natural or artificial, is falling on your object or configuration space point or node. That light is reflected to the camera, and through camera now you are capturing that scene or image. Now first all this collected data is given to analog to digital converter. Then sampling and quantization is applied, and all visual information is encoded. Either this visual information can be stored, or again, if you are having video data, then frames can be mapped. So either you can have image or video, two aspects are there. So either you have frame grabber or image storage, and then this image is given to the processing and analysis. Now this is what exactly block diagram of robotic vision system. Starting from initial point, there is an environment, that is what task environment, where robot is working. This robot is manually connected with robot controller. Robot controller has got hardware interface with computer and other higher processors. On the same unit, the computer and the processor is interfaced to camera, and camera is now oriented towards the task environment. In this task environment now, essential thing is the light, because without light, scenes or video cannot be captured. So continuously light is falling on the task environment, and camera is capturing all the scenes, images, and they are passed in the, first of all, storage space. It can be either auxiliary storage or you can have permanent storage. On second side, in program memory, various algorithms are there. They are picking up the stored scenes and images. At console or workstation, there are monitors. This will be showing you resultant information, that is visual information. So human operator can monitor through that. Main blocks here are robot controller, the task environment, the camera, the illumination, hardware interfacing, computer processor, monitor and peripherals, storage units.